This next lesson is going to focus on limits of trigonometric functions, and there are a couple of limits that we are going to need to look at. So we have three formulas that I'm going to ask you to know for this course. The first one is the limit as x approaches plus minus infinity of sine x over x equals 0. So sine x over x, it's kind of a funny looking graph, is a great example of a graph that has a horizontal asymptote that crosses its horizontal asymptote. So it kind of goes back and forth and gets smaller and smaller on both ends as it approaches plus minus infinity. So it still has its periodicity, it goes up and down, but the periods are not the same. Each period it kind of gets smaller and smaller and smaller and smaller and smaller. Okay, so a lot of what we're going to be doing is looking at this. We have another one related to sine x over x, which is the limit as x approaches 0 of sine x over x, which would give us 0 over 0. Sine x at 0 is 0, and x at 0 is 0, is equal to 1. And that's something you can see if you graph it. So this is number 1 thing to know. This is number 2 thing to know. And number 3 thing to know involves cosine, which is the limit as x approaches 0 of 1 minus cosine x over x is equal to 0. So these are the three things you need to know in order to be able to manage some of the trig limits. Generally, if it's just trigonometric functions, you plug in the point. And if you plug in the point and you have an answer, then that works. You also have to be a little careful with tangent. So sometimes tangent has vertical asymptotes, so you may see a vertical asymptote, or if you have a fraction, there may also be a vertical asymptote involved, and you will see that. So it's always important to check, do you have 0 over 0, and you're going to use one of these three formulas, or do you have 1 or another number over 0 and you have an asymptote. Okay, so let's look at a few examples of our trig limits. So example number 1, we have the limit as x approaches infinity of sine 2x over x. So generally when we're looking at the sine x over x, what we want to be able to do is make this look like sine x over x. But x can be anything. So what I notice is here I have a2x. So if the stuff in the denominator looked like the stuff that's inside the sine function, then I'm good. That's sine of something over that same thing is still going to give me the limit as x approaches infinity. That will still be 0. So what I want to do is I want to make this look like that. So what I'm going to do is I'm going to multiply the numerator and denominator by 2 over 2. So multiplying sine 2x by 2, the 2 comes out front in our regular notation. So this is the limit as x approaches infinity of 2 sine x, 2x over 2x. Now we see that these two things are the same, which is exactly what we want. So we know that this limit right here, so remember, we have the product rule for limits, is that the limit of a product is the same as the product of the limit. So this is the same as the limit as x approaches infinity of 2 times the limit as x approaches infinity of sine, oops, there's an extra x in there, sine 2x over 2x. Okay, so we can take our individual limits. So this is the same as 2 times 0, which just gives us 0. Okay, so we are allowed to split that up. And generally what you're trying to do is you're going to be trying to separate out a 2x somewhere. Let's look at another example. Okay, the limit as x approaches minus infinity of sine 2x over 4x. Well, again, this is just a numerical one. We want the 4x to be a 2x, so I'm going to multiply numerator and denominator by 1/2, because no, I can always pull that 1/2 out in front. Okay, so this gives me the limit as x approaches minus infinity of half sine 2x over 2x. Okay, so this is the limit as x approaches minus infinity of 1/2 times the limit as x approaches minus infinity sine 2x over 2x. And we could have just also pulled out 1/2 as a constant multiplier. That would have been fine as well. So this is equal to 1/2 times 0, which is just equal to 0 again. So let's see what happens when it's not a constant. So example 3, we have the limit as x approaches infinity of sine x squared, and we put the x squared there just to make sure we know it's not sine of x squared, it's sine of x squared over x squared. Okay, so limit as x approaches infinity of sine of x squared over x squared. Oh, sorry, whoops, let's make that just over x. Okay, we can multiply this times x over x. So we want to have just an x squared in the denominator, so this is the limit as x approaches infinity of x sine x squared over x squared. These are now the same. Again, product of the limits is, the limit of a product is the product of the limits, so this is the same as the limit as x approaches infinity of x times the limit as x approaches infinity of sine x squared for x squared, which is equal to x times 0, the limit, and which is the limit as x approaches infinity of x times 0, which is equal to 0. Infinity times 0 still is equal to 0. Okay, so example 4, we're going to use one of our other problems. So we have the limit as x approaches 0 of sine x. We're just going to do a regular trig limit. There's no fraction. I'm just going to plug in x equals 0. This is equal to sine 0, which equals 0. Okay. So here we have the limit. Example number 5, I have the limit as x approaches 0 this time, not infinity. We've been doing a few of those, of 5 sine x over 2x. So I can think of this as being multiplied by a constant of 5/2. So this is equal to 5/2, the limit, and we're treating this as a constant multiplier now. The limit as x approaches 0 of sine x over x. This limit is equal to 1, so this is equal to 5/2 times 1, which is just 5/2. Okay, and one last example. These trig limits, generally we're not getting into anything too complex, but we may need to rewrite things like tangent in terms of sine and cosine. You might need to use a Pythagorean identity somewhere, and it's always good to have your double angle formulas for sine and cosine just kind of hanging out just in case you need them. Okay, so this is the limit as x approaches 0 of tan 3x over x. So we have a 3x, and this makes it look like we might have to use a double and we don't really have a triple angle formula, but we do have a sum of two angles formulas. But let's see what we can do without it, because remember, we're trying to take a limit. So we want to think about what are our three formulas that we have. So we know that we're going to 0, so we know 2 about 0. So the limit as x approaches 0 of sine x over x equals 0, and the limit as x approaches, equals 1, and the limit as x approaches 0 of 1 minus cos x over x equals 0. So we want to get it to look like one of those two things, and then we should be able to take a limit. Okay, so let's just check, plug in x equals 0. Well, the numerator goes to 0, and the denominator goes to 0. So this is going to be indeterminate, and we are going to need to do something before we evaluate this limit. So this is equal to the limit as x approaches 0 of sine 3x over cos 3x, and all of that over x. Okay. So what we are going to do now is we are going to rearrange this. And again, I don't really want to try to use my 3x. I want to try to use something else. So this is equal to sine 3x over x times cos 3x. So what I notice now is I have something right here. If you look at just this part that I've outlined in yellow, that looks like it could be a sine x over x. The problem is I don't have a 3 in the denominator. But putting a 3 in the denominator is relatively easy. I just have to multiply numerator and denominator by 3. I'm going to multiply by 3 over 3. So I've got now the limit as x approaches 0 of 3 sine 3x over x, 3x, we need that 3 in the denominator, cosine 3x. So, as I said, the stuff I highlighted in yellow, this is the part I want to go together. This makes me my sine 3x over 3x is the same as sine x over x. It's a sine something over something. It doesn't matter what that something is, as long as it's something. So I'm going to separate that limit out because we're multiplying. I can write this as the product. This is the limit of a product. We think of this as being sine 3x times 3 over 3x times cosine 3x. So this is the limit as x approaches 0 of sine 3x over 3x times the limit as x approaches 0. We've got a 3 left over in the numerator and a cosine 3x in the denominator. And because it's multiplication, I can kind of pick and choose what I want in each part. So finally, we can evaluate the limit on the left. That's going to be equal to 1 when we plug in 0, because that is one of our limits that we are supposed to know. Sine something over something equals 1. Now, when we approach 0, we plug in 3 times 0. Cosine of 3 times 0 is just cosine of 0, which is 1. So this is 1 times 3, which equals 3.